Okay, guys, let's look at the first worked example on this very law we're discussing today. Now, look at what we have. Show that carbon 4 oxide, which is CO2, and carbon 2 oxide obey the law of multiple proportion. Now, we talk about carbon 4 oxide and carbon 2 oxide. Now, look at what we have. Carbon 4 and carbon 2, oxide and oxide. So this oxide here is oxygen. When we talk about carbon 4 oxide, this is carbon having an oxidation number of 4, or valency of 4. Oxygen has a constant valency of 2. So by the time we bring this together, we've done this already in our previous lesson on how to write chemical compounds, chemical formulas. So that's going to be C2O4. So when we break this down, we have CO2. So that's carbon 4 oxide. So sometimes we call it carbon dioxide. Carbon 4 oxide is the IUPAC name. Those are old name. So CO2. So next we have is carbon 2 oxide. Carbon 2 oxide. What do we have? We have C2O2. This takes out this. And then we have CO. This is carbon monoxide, the old name. The IUPAC name or the new name is carbon 2 oxide. Now, this two, how do we use this two to buttress or to show the law of multiple proportion? How do we use this to explain what John Dalton saw, while working on different atoms of elements? Now, this is it. Now, don't forget the law. The law we're talking about there is provided the various atoms of a given element combined with a fixed, mass of an atom of another element, to do so in a simple numeration. Now, they combine to form multiple compounds. Now, the first compound we have is carbon 4 oxide, which is different from carbon 2 oxide. They are entirely two different compounds. But carbon and oxygen, play huge roles in this in the derivation of these two chemical compounds. So look at the very first one is carbon 4. The next one is carbon 2. So how do we show that this law is going to obey? Now it's very simple. We look at the first is carbon 4. Let's say carbon 4 and carbon 2. By the time you check them, 4:2 is 2 here 1, 2 here 2, so it's just 2:1. This is a simple way to explain it. Carbon 4, carbon 2. So when you work on them, it's 2:1. But there's another way we can work on them. Because when you look at CO2, let's look at the atomic mass, the molecular mass of this. Carbon 4, look at carbon. Carbon was the atomic mass of carbon. Atomic mass of carbon is simply 12. Oxygen is 16. So when you look at CO2, what we really have here is this one atom, these two atoms. So what we have here is 12 grams of carbon plus 16 times 2 is 32 grams of oxygen. That's what we have for the CO2. And also for the CO, what we have here is 12 grams of carbon combining with 16 grams